Hi, my name is Nandini. My project title is Solar Tracking System using Hybrid Network. Uh, Coming to the project client details, client name is Nasir Mohammed. My company name is Career DC. And the project supervisor is Vanud Kumar. So, coming to the overview of the project, solar panels are becoming trendy day by day. Solar panels are eco-friendly and very easy to use. The efficiency of solar panels can be improved using different approaches, single axis and dual axis tracking system, and these both are used for the movement of the solar panels. So coming to the client requirements, the efficiency of current solar system is to be increased by 30%, and the hybrid system is used for updating the current system. The system design can be integrated with already installed system. The design should be generic as well as for the other sites as well. So coming to my project design, uh, the components and the process that are to be used as it can be shown in the high level design program. The sun rays are collected by the solar panels and LDR sensors. LDR sensors send signals to the controller as per the reading, and the controller with the help of the sensors uh, decides whether to move the panels or stay in the current position. The controller then sends signal to the motor for moving the solar panels, which is noted with the help of actuators and other with the help of the controller as well to identify the current position of the solar panel. So it is basically a dual axis solar tracking system, and the controller controls the motors via drivers. The controller sends a signal to driver after each and equal interval. Dual axis can allow movement in two axes, vertical as well as horizontal. So efficiency is increased by 25 to 30%. So basically we are using, this is hybrid network, so we are using the both vertical and horizontal axis as well. So coming to the components for this project design, so we are using the Arduino users, jumper wires, LDR sensors, resistors, transceiver, solar plate, and the batteries. Coming to the Arduino, Arduino is a microcontroller used for the project, and Arduino, is a very basic and easy to use, and it's microcontroller. It's basically a tiny microcontroller which controls the entire approach. So jumper wires is used for connections and connecting sensors, controllers via broadband. LDR sensors. LDR sensors are light sensors and they can detect the intensity of the light. And resistors, it's basically used for providing the protection and applying the desired current to the screen, sensors, and other components. So transceiver, it's used for sending and receiving the data wirelessly. It is used connected with the controller, which decides the data is being sent. So coming to the solar plate, solar panel is used for producing electricity using solar energy. It converts solar energy into electricity. So batteries, we are using the batteries for this. It is used for powering up the controller and the other sensors. So coming to my single design approach, um, so in this, the part A shows the solar, it is the diagram for the solar panels and which position they are placed. This design is more focused on the mechanical aspect of the solar frame and the movement of the solar panel. LDR sensors placement can be seen in a part A. The sensors can be seen in a part A, and the two sensors, the two sensors send data to controller for the comparison, and this difference will decide on which direction the solar panel should move. So with move by the controller, and the controller motor will rotate the gear placed within the frame, and the frame on which the solar panel is placed. Gears help in moving heavy objects with the small force. So it can be said that the gear can increase the torque and reduce the speed or vice versa. In this scenario, speed is not necessary. We basically focusing on the angle, um, with a very slight angle and after long intervals. So torque increase can help in energy efficiency as well as the smaller motors can be used for and is for the cost effective. The stand helps to support the basically the stand helps to support the position of the whole system on whichever the plane is installed. And the motor and helps in smooth movement of the solar panel and is fixed with the two LDR sensors which provides reading to the controller and the movement of the solar panel. So basically it's when sun rays fall on the solar panel, the two sensors detect the sun rays and they send data to the controller, and the controller reads all the data from which the sensor sent, and it sends data to the motors and decides whether to move the position or to still stay in the same current position. So, and this design is based on the mechanical part of the project. We are using the gears to divide the load movement between the gear and motor. So with the less torque and the frame can be moved. So two LDR sensors are placed on edges of the solar panels to get the readings of the sunlight, basically. So coming to the initial implementation, the solar frames are made with the size of solar panel. The solar panel gets fixed into the frame and the motor is connected in the frame using gears, and the controller is wired to it using motor driver. The LDR sensor connects in center of each side of the solar panel for maximum output, in which in turn the interfaced with the controller using the readings with the help controller to design which direction the solar panel should move. This project will be implemented using Arduino Uno microcontroller. Arduino Uno is a mini computer with the less processing power, but it will be enough for the small scale project. So this is basically a very small scale project. So Arduino Uno is a microcontroller, and that is more than enough for this small scale projects. So Arduino Uno has a development environment provided by the company, which is very user friendly and makes it easier for layer which cannot code to write the code in a C language with some basic tutorials. So programming the Arduino board, we need to connect the programming the Arduino board with the laptop computer using USB cable, attaching PC and the controller. Arduino will be powered by the USB connections, and but an external battery can also be used if needed, which keeps Arduino active even if it's not attached to PC. For basic understanding, we will start the work with the basic program and blinking the light on Arduino board. First, we will download the IDE Arduino for basic coding on Arduino. So for the initial implementation part, basically this entire project is working on the single and dual axis. The that's the like single and dual axis is basically the both horizontal and vertical, which is called as dual axis using tracking the network. So the main motive of the project is to detect the sun rays on which positions and the panels which positions they are moving. Basically when sun rays fall on the solar panel, and the LDR sensors immediately detect the light rays and sends data to the controller. And the controller collect all the data from the sensors, and it sends data to the motor, and they decide whether to move the solar panel or to still stay in the same positions, which is noted with the help of actuators. And the readings which are coming up, the motor which is collecting the readings are basically read with the actuators. Actuators is basically used for the reading of the controller. So the Arduino plays a major role for controlling the entire process. It is a very microcontroller but easy to use, and it's very basic and easy to use as a microcontroller. So in these, the sensors basically working on the both on both phases, like the dual axis as well as the single axis. So these sensors detect the sun rays which are basically falling on the panels. The panels are fixed from like vertically positions at the top and the bottom. So in implementation, we basically we are using the entire thing in the code or C language, and these connections are made with the USB, and the components which we used are transceivers and the resistors. They are connected with each other to make the readings better and to see the readings are coming up properly, and to check the movement of the solar panel after each and every, like e- each and every reading. But the readings are very different. So coming to the Arduino will be powered by the USB connections, but an external battery can also be used if we needed. Not only the battery we are using is not enough, we can use the external batteries as well. So basically this is the entire approach of my design, and thank you so much. So coming to the references, I have used two references, R.Islam and P.Chauman Jamarin. So these are my references. Thank you so much for this presentation. Thank you.